Complex fractions. All right, so in this video about complex fractions, basically a compound fraction, or some people may say complex fraction. I usually say complex fraction, is a fraction in which the numerator, the denominator, or both themselves are fractions. So some examples of complex fractions are things like this. Let me give you 1/5 divided by 2/3. This is a complex fraction because it's a fraction divided by another fraction. So the one way of actually simplifying this is actually writing it horizontally. So horizontally, what I mean by that is this is now 1/5 and then divided by 2/3. So now instead of a fraction of a fraction, you see it in the way that you typically see two fractions divided by each other. So if that's the case, it's 1/5 times the reciprocal. So 1/5 times 3/2. So when you multiply that, it's going to be 1 times 3 in the numerator, which is 3, 5 times 2 in the denominator, which is 10. So that basically means that 1/5 times 2/3 is the same thing as 3/10. Another way you can think about that is simply take this denominator and multiply by the reciprocal of the bottom. And then you get 1 times 3 and 5 times 2. And that will always work. So either you write it horizontally or you simply multiply the numerator by the reciprocal of the denominator. So instead of having just numbers, complex fraction can also be written as a polynomial divided by another polynomial, divided by another fraction, which is a polynomial over another polynomial. So again, best way to think about it is writing as horizontally. So I'm going to rewrite the numerator as 2x squared subtract 3x subtract 2, just as it is. And whenever I see x squared subtract 1, I just can't look at it and not factor it. So whenever I see that, I just automatically know to factor it. Factors be x subtract 1 times x plus 1. The denominator is still the same thing as right now, 2x squared plus 5x plus 2 divided by x squared plus x subtract 2. And now I can start factoring all these things and also multiply by the reciprocal. So this is factorable, that should be factorable, and of course that's factorable too. So if I took the top number, 2x squared subtract 3x subtract 2, and I start factoring that, you probably multiply that by 2 and call it x squared subtract 3x subtract 4, which we know factors to be two binomials, and they are x and x. This is an unlike sign, so one's positive, one's negative, and multiplies to be 4, and adds to be 3, so it has to be a -4, +1. And since I multiply by 2, I divide that by 2 and divide this by 2. So this is now 2x plus 1 times x subtract 2. So the numerator are those. So I can rewrite this now as, instead of having this, I can call it 2x plus 1 times x subtract 2 divided by x subtract 1 times x plus 1. You want to factor all these things because you want to see what can cancel out when you multiply this. It's going to be multiplied by the reciprocal of this. So now the numerator is going to be this, which you want to factor. I think I can figure out what that factor would be by looking at it. It's going to be x and x, unlike signs, and has to multiply to be 2 and add to be 1, so +2 and a -1. And the bottom part, I would just rewrite it someplace else and factor it. So given 2x squared plus 5x plus 2, you factor using this, you get x squared plus 5x plus 4. So that means that factors to be x plus 4, x plus 1, divide those by 2, and it's x plus 2 times 2x plus 1. So the new denominator, when this has been flipped, is now going to be x plus 2 times 2x plus 1. All right, so we're going to take this fraction and multiply it to this one, kind of out of space. So all these words, hope you already have them. I'm going to erase that stuff now. So you can keep writing on the same line or whatever. I'm going to take it and move it a little bit. You don't have to do it this way. You probably should just write it beneath and put it up here. So after I multiply these things, I should have as a numerator 2x plus 1 times x subtract 2 times x plus 2 times x subtract 1. And that's divided by all these multiplied together. So it's divided by x plus 1 times x subtract 1 times x plus 2 times 2x plus 1. And then I'll look for what can actually cancel. So in that line, I see a lot of stuff that will actually cancel out. So in the top, I could go ahead and cancel out x plus 2's here cancel to be 1 over 1. X subtract 1's cancel to be 1 over 1. The 2x plus 1 and the 2x plus 1 cancel to be 1 over 1. So the only thing I left in the numerator is x plus 2, or better yet, x subtract 2. Divided by x plus 1. So my final answer is x subtract 2 divided by x plus 1 after you reduce this complex fraction. So that's pretty much it. That's pretty much as hard as it gets with complex fractions, having a fraction divided by another fraction. That's how it goes. So with that being said, good luck.